this is Britt Caswell with another example video. In today's video, I am covering Lesson 6.1 from the Savvas Realized Algebra 1 textbook, but it's with problems that I've created that are similar to the ones that are shown. Alright, so this is the quotient property, and I'm just doing an additional walkthrough to help you guys to see kind of how to go about doing it. So what I've done is I've actually written out a procedure that I'm going to follow to show you how to solve a problem that looks like this. Alright, notice that we have expressions that are raised to an exponent equal to 1. So our first step in our procedure is to make sure that each term with an exponent has the same base. Alright, the base is this larger number here that's going to be raised to an exponent. So what I'm noticing here is that I have a base of 6 here. So I probably need to change the 216 to a different base because 6 doesn't really break down any further. So what I'm kind of anticipating here is that because the 6 can't be broken down any further, I feel like 216 has to be some kind of multiple of 6. Okay, so what I'm doing is I'm creating a factor tree and I'm dividing 216 by 6 to see what I get. And when I do divide it out, I get that it's 6 times 36. And I know that 36 is also 6 times 6. So 216 is 6 times 6 times 6. Or as I would prefer to say it, 6 cubed. So what I'm going to do is I'm going to rewrite the 216 here. Let me just highlight that in the blue. So this part in blue, I'm going to rewrite it as 6 cubed. So this is what this looks like. So I have 6 cubed. Now remember that 216 is raised to a power, right? It's raised to the 1/8. Over 6 over x to the 8, I'm sorry, 6 to the x over 8 equals. Now I know a little later on that I'm going to be setting the exponents equal to each other. I can only do that if the right-hand side of my equation is also 6 raised to some power. Alright, so another property that we need to remember is that if you raise any number, including the number 6, to the 0th power, it will equal 1. Alright, so I'm using that property to rewrite the 1 as a number with 6 as a base and an exponent. Because I know that down at step 3, I'm going to need 6 to some power. Should have given myself more room here, but... Alrighty, so now here's the equation that I have. So now step 2. It says, use the quotient property to convert into one term with an exponent equal to another term with an exponent. Okay, so I need the left-hand side of this equation to have 6 to some power. Okay, I don't want a bunch of other stuff. So the first thing I'm going to do is I'm going to use my power of a power property right up here at the top. Alright, because I have 2 exponents with this 6 and I don't want 2 exponents, I want just 1. So the power of a power property says that I can multiply those 2 exponents together, and that's what I'm going to do. So 3 times 1/8 is 3/8. So the top of this ugly fraction is now 6 to the 3/8. Okay, so now I'm actually using the quotient property for this step 2. The quotient property says if you have 2 things with the same base, you can create one base when there's a division going on where you're subtracting the exponents. So I'm taking 3/8 and subtracting x over 8. and it's going to be equal to 6 to the 0th power. Step number 3 now says to set the exponents equal to each other. All right, so I'm ignoring the 6's, I'm removing them, because if I have 6 to some power equal to 6 to some power, they have to have the same power, right? So I'm taking the exponents and I'm just setting them equal to each other. Now on the examples that we saw in class, these had different bases, so it was a little bit harder to subtract them. So what I was giving you guys in class was an idea that said if there's a fraction, multiply by the least common denominator to remove it. Okay, so that's what I'm going to do here with the 8s. Although I could very easily just, just combine those because they already have a common denominator. But I'm going to times by 8 just to get rid of those 8's in the bottom. Okay, so here's what happens. Remember, fractions are division. So if I'm multiplying by 8 and dividing by 8, those cancel each other out, and that leaves me just with that main number that's on the numerator of the fraction. And that same thing's going to happen here. So 8 times x divided by 8 leaves me with just x. And then here, 8 times 0 is 0. So this leaves me asking myself, 3 minus some number equals 0. So what number do I subtract from 3 to make it 0? Well, that would be x equals 3. So if you follow this procedure, you should be able to solve similar problems to this. So now let's go ahead and let's try another one. So the first thing we need to do, right? Make sure that each term with an exponent has that same base. So that's what I'm going to do here. Now notice the 5 can't be broken down any further, right? 5 is prime. So it's these other two that I need to go ahead and break down. So 25 I know is 5 times 5. So for the 25, I'm going to call that 5 squared. 625 I know is 5 times 25. And I know that 25 is 5 times 5. So I'm going to call the 625 5 cubed. So I'm going to rewrite this equation, replacing the 625 and the 25. So I have 5 to the negative 3/8 equals 625, which is 5 cubed, to the x over 8, divided by 25, which is 5 squared, to the 5/8. So now all of these have that nice same base, which is good. Now it says use the quotient property to convert into one term with an exponent equal to another term with an exponent. Okay, so I need to figure out how to make all of this right-hand side 5 to some power. All right, so to do that, I'm going to go ahead and I'm going to use my power of a power property to get rid of these parentheses. Okay, so the left-hand side stays as it is. And on the right-hand side, I'm going to multiply each set of exponents. So this turns into 5, and 3 times x is 3x over 8. And down below, I have 5, and then 2 times 5 is 10 over 8. And then the quotient property says if you have two numbers with that same base that are being divided, you can convert it into a number with a single base that's being subtracted. So I'm going to turn that into 5 to the 3x over 8 minus 10 over 8. So now I have 5 raised to a power equals 5 raised to a power. So that means that those powers have to be the same. So I'm going to go ahead and get rid of the 5's and just set the exponents equal to each other. And then when I look at this, I say, ooh, there's those ugly fractions. I don't like fractions. They stress me out. So I'm going to go ahead and multiply by the least common denominator, which here, these all have 8 in the bottom. So I'm just going to multiply everything by 8 to get rid of the fractions so that I don't stress out. So here we go. So all of these 8's will cancel out with the 8 that I'm multiplying by. So I'm left with negative 3 equals 3x minus 10. And now I just need to solve for x. So to start solving for x, I need to get rid of the subtraction first. So I'm going to add 10 to each side of the equation. So I get 7 equals 3x. And my last step to get x alone is to get rid of that multiplication of 3 by dividing by 3. Oh, and I thought I left myself enough room. Not quite, so I'm just going to write it to the side a little bit. I get that 7/3 equals x. Alright, for the sake of clarity, I'm just going to draw some straight lines here. So again, here's what I did, right? First thing, I needed to write all of these numbers with the same base. So I looked at the numbers that I had and I said, well, 5 is prime, so 5 can't be broken down any further. So then I focused on the 625 and the 25. And I did my factor trees on them, and I figured out that they're 5 cubed and 5 squared. So I rewrote the 625 and the 25 as a square and a cube. And then I used the power of a power property just to change those exponents. Okay, I multiplied them together. I'm just going to draw a line between these to clarify things. So I used the power of a power property, and I multiplied the exponents. And then I used the quotient property. And with the quotient property, I was able to subtract the exponents and make just one base. And then I took all the exponents and just set them to each other. I got rid of the 5's. I said, ooh, fractions. I got rid of the fraction by multiplying by 8. And then I finished solving for x. And then the last problem that you guys will see on this problem set has to do with writing an expression in exponential form. Alright, so we're taking these radicals and writing them as exponents. So I just want to remind you of what the exponential rule looks like. It says that if you have a to the m divided by n, that's equal to the nth root of a to the mth power. Which sounds a little silly, doesn't it? So this is the rule that I'm using to help me with these problems. Oops. So let's go ahead and let's start with this one that I'm circling in blue. Okay? So my base is going to be whatever my radicand is, the number under the radical. So I'm going to have 11 raised to some power. Now the index, the number outside of the radical, that becomes the denominator of the fraction. And the exponent becomes the numerator. Now remember, just because these fractions are an exponent doesn't mean that they don't behave like normal fractions. So I can actually reduce this from being 7 over 7 to being a 1. And 11 to the first power is just 11. So that would be my final solution. Alright, now the one with the yellow smiley next to it. Again, I have an 11 as my radicand, so that's my base to my exponent. In terms of my fraction, the 4 on the outside comes down here to the bottom, and my 3 at the inside becomes a 3 in the numerator. And this is as far as I can take it because that fraction cannot be reduced. Alright, so now this one with the green sun next to it. Alright, now my base has changed, right? That radicand is now a 3. The 7 is on the outside of the radical, so it becomes my denominator. And my 4 is my exponent, so it becomes my numerator. And that fraction, 4/7, can't be reduced, so that is all that it is. And then our red one with the red tornado. Alright, notice that it doesn't have a number outside where the index goes. So if they don't write a number where the index is, there's an imaginary 2 there, okay? And that 2 becomes the denominator of our fraction, and the exponent in here, the 4, comes up here as a power. Now, I'm not 100% sure if Savvas would accept this as an answer, okay, because this is not fully simplified. Remember how I'm saying that, like here, the fraction could be reduced? That happens here with the red as well, because 4/2 is the same thing as squaring, and 3 squared is 9. So this one is the fully simplified. But if they're just asking you to write it in exponential form, Savvas might want the 4/2 part here. But there we have it. There are a few more examples to help you guys get along with some of this quotient property with Savvas. Until next time.